subatomic models. After the discovery of these fundamental subatomic particles, now the question was how they were arranged within the atom. The atomic models proposed by different scientists are briefly explained below. The Thomson atomic model. J.J. Thomson in 1898 proposed that an atom was a sphere of positive electricity having a size of the order of 10 to the power minus 10 m. The whole of the positive mass and the mass of the atom are uniformly distributed. The negatively charged electrons and the positively charged protons exist as beans in a jelly. This model is compared with a watermelon in which the seeds are embedded. Sometimes it's called the watermelon model. The whole positive charge of the atom is equal to the total charge of the electrons. The limitation of this model is, though it satisfactorily explains the neutrality of the atom, it cannot explain why atoms are stable, because the electric charges when squeezed in a small volume are expected to repel each other. Another drawback is this, that the model cannot explain the scattering experiments carried out by Rutherford in 1911, and so it was rejected. Rutherford's atomic model, or the nuclear model. The gold leaf experiment. One important experiment that had an important bearing on the development of the structure of the atom was that of Rutherford's gold leaf experiment. In 1911, Rutherford performed some scattering experiments in which he bombarded thin foils, that is 100 nm thick, of few metals such as gold, silver, copper, etc. with a beam of fast-moving alpha particles, that is helium-2 plus ions. The source of the alpha particles used was radium, a radioactive element placed in a block of lead. Slits were used to get a thin beam. The presence of the alpha particles at any point around the thin foil of gold after striking it was detected with the help of a circular zinc sulfide screen. Observations: most of the alpha particles, that is 99.9%, pass through the foil without any deflection. Very few of them underwent deflection through small angles. Only 1 out of 20,000 of the alpha particles was deflected back, that is, through an angle of more than 90 degrees. From the above observations, Rutherford drew the following conclusions. Since most of the alpha particles pass through the foil without any deflection, there must be sufficient empty space within the atom, that is, most part of the atom is hollow. Since few of them were deflected through small angles and they are positively charged, so when they pass in the vicinity of the concentrated positive charge in an atom, they get repelled and suffer deflection. That is, the positive charge is concentrated somewhere in the atom. The alpha particles possess considerable mass. The returning back of alpha particles indicates that they have collided with something which is quite heavy. Moreover, since the number of such alpha particles which return back is quite small, so the space occupied by the heavy part of the atom must be very small. There is something very heavy in an atom occupying a very small space. Nuclear model of the atom. On the basis of the conclusions derived from the above stated experiments, Rutherford proposed a model of the atom which is known as the nuclear model of atom. The important features of his proposal are as follows. Almost the total mass and the total positive charge of an atom is concentrated into its center, called the nucleus. It is heavy due to the presence of an entire mass here. The density of the nucleus is of the order of 10 to the power 14 grams per cc.